How was everyone's break?
Boring.
Not long enough? I feel that. I could have used like 2 more days. We did.
There's snowballs at night.
Oh, that is no fun.
Yeah. We were living out with my grandparents' house and it got boring. So we left.
My notes. My notes. Okay. Let's amend attendance yet again. Okay, so there's gonna be you're gonna need paper and a pencil for sure. There's gonna be some new vocab, stuff you definitely have not seen before. So I'm pretty much out of pencil, but here's paper on the top. Have any of you learned what sequences are in an English class? Sequences? Maybe a sequence of events or something like that. Has that been a vocab word for you at all?
Probably.
Okay, so what does it mean for something to be a sequence? One after another. Perfect. Okay, so I want you to look at this and tell me how the pattern is growing.
Growing by 3 every time.
Okay,
It's growing by 1 and 3.
what do you mean by 1 then 3?
1, 3, then 1, 3, 1, X, Y.
Oh, okay, I see what you're saying. So 1 row with 3 in it. Okay. How do you see it, the 3 being added?
X.
Okay, no, I saw how you did it. Anybody else have a different way? There's no right or wrong answer. Everybody sees. Okay, so pushing up from the bottom. Okay.
Or maybe it's dropping 3 on top.
Or dropping 3 on top.
One right there, it just makes another one keeps going.
Okay. So how many circles would there be if each one of these is considered a case, right? So this would be case 1, case 2, case 3, case 4. What if we went back to case 0? How many circles would we have?
1. Just
1. How many would we have if we went to case 5?
Sorry, more than that.
15. So let's see how many we've got here. 3,
14.
4,
Yeah, 16.
12, 13, so 16.
Yeah.
Okay, so now we're gonna look at it as numbers. All right, where case 1 has 4, case 2 has 7, case 3 has 10, case 4 has 13. You okay with that so far?
Yeah.
Okay, so this is a sequence of numbers. Okay, so vocab, a sequence is an ordered list of numbers that often forms a pattern.
Like 10, 20, or 5, 15, and so on.
As long as it forms a pattern, it would be considered a sequence.
As long as it just like repeats itself or something.
Mm-hmm.
What about what about the pattern that never repeats itself?
Then it's not a sequence. Okay, term of a sequence is any number in a sequence. And we always go in order. So like the first term would be term 1, the second one would be term 2, and so on. And the common difference is the difference between consecutive terms in an arithmetic sequence. These are our first three vocab words for today. Sequence, term of a sequence, and common difference. They will all be
Nice to say
important.
often, doesn't mean it always feels better.
So I will be using these a lot in today's lesson, so you might want to write down what they mean, so you know what I'm talking about. And just a little heads up, you will not have a test at the end of this unit. No, weird, huh? You'll have a project, and it involves sequences. It's a rather fun project that I enjoy grading. You'll be creating, you'll be creating a slideshow for me. You're gonna create your own sequence and determine what kind of sequence it is and what its function is. And you can draw it however you want. I had somebody last year do pictures of cats. Another student did peg ones. Some people did squares, some people did circles.
Some people did triangles.
No, your sister did peg ones though.
Yeah. Yeah. We had that discussion, yes, we did.
We did. We'll have the computer card a couple days, and you'll get time in class to work on it. If you missed something along the way today with your notes, they are on Canvas already. Had to make sure they were up for Jeremy this morning. Because it's backwards, so trying to write his notes backwards is just cool. Okay, so we're gonna look at our pattern as numbers. We have our case number and then the term of the sequence. Does this look like anything familiar to us? What does it look like?
Input, output.
Huh?
Input, output.
Input, output. Absolutely. Our case number is our input. The term of the sequence is the output. So to determine if a sequence is arithmetic, we have to find what we call the common difference or the first difference. Okay, and to do that, we take the output and we subtract the output before it. Okay, so it would be 7 minus 4. What does that equal?
3.
And then 10 minus 7,
3.
13 minus 10,
3,
And what did we say, how many did we say would be if we went to fifth?
16. 3.
If these all come out to the same number, if it is a constant number, then it is an arithmetic sequence. If you find the first difference and it's not the same, it's not constant, then it is not an arithmetic sequence. Okay, that's super important to know, that if the first difference is constant, then it's an arithmetic sequence. And if it's an arithmetic sequence, it can be expressed as a linear function. Okay, which is something that we've talked about before. Right, it's kind of full name being it, so. Okay, so taking it from, it's all right there, so. Okay, we use some different notation when we're talking about sequences. Okay, we use n to talk about the term. What in the world happened there?
The third
Hold on. Hey,
of
we're gonna fix that right now. There we go. So n is the term number in the sequence, and a of n is the value of the nth term of the sequence. For example, a of 1 equals 4, right? So we put in 1, we get out 4. A of 2, stop talking. A of 2 equals 7. We put in a 2, we get out a 7. Okay, you with me? We use n to describe what number of term we're looking at. Okay, we also use subscript. Don't know what subscript is? So superscript is when we do like x squared. And then subscript is when we do it at the bottom. So there's a little number at the bottom. So a lot of times, instead of using a capital A of n, we will use an A subscript. Okay.
Hey, that looks like a certain thing in science.
Does it? Well, I hate to break to you, but science is the explanation of the universe, and math is the language that explains science. So science and math are very intertwined.
Like,
All right, so A of 1 would also be the same as A sub 1. They're interchangeable. You will see this one a lot more often. You'll often see A sub n, meaning what is the value at term n? Which means they want the most generic form of that equation that you can come up with. Okay.
Can you go back there?
Either one of them works. They mean the same thing, just like f of x equals y, they mean the same thing. But you will see this one way more often than this one. Okay, so don't let it throw you off. Either way is correct. Why did you need to go back? This thing right here? So the big question we're going to face is, how do we determine what the equation is
Okay.
for a function or for a sequence? The first kind of formula we're going to talk about is a recursive formula. There are two different ways to write these formulas down. There's recursive and explicit. We're going to do recursive first. Recursive in math means to repeat a process over and over again, using the previous output as the new input. Okay. So a recursive formula relates each term of a sequence to the term before it. Okay, so it's composed of the initial value and a rule for generating the sequence. A sub 1 is always the first term of the sequence, Right, so the one that we've been doing, A1, A sub 1 is 4. So you would write it as A sub n equals A sub n minus 1 plus D, where D is your common difference. Okay, and we're gonna do an example of it so you can kind of see how this works. Because you're looking at this going, this is Greek. I don't know what the crap you're saying. This means nothing to me, right?
Yes.
The biggest hurdle with sequences is figuring out the notation. And getting comfortable with it. Okay, so for our one that we've been doing, right? We put in 1, we got out 4, we put in 2, we got out 7. Our common difference was 3. So if we start with an A sub n equals A sub n minus 1 plus 3, and then let's go for A sub 6. Let's find out what our 6th value would be. Okay, so we would put A sub 6 minus 1 plus 3. So when I do that math, I get A sub 5. We know what A sub 5 is, right? What is it?
It's 16.
It's 16. So we just plug in that 16.
And that is.
So what it's saying, hold on, okay. So what it's saying is take the term before the one I'm looking for, plug in its value, add 3, I'm gonna get the next one. Not so bad, right? I can add 3 a million times. That's not a hard thing to do. But if I were to ask you to find the 52nd term, you would have to do every single number up to 52. Do you want to have to do that much math to find out one value? No, none of us want to do that. Could be a very long and laborious and obnoxious process. It takes way too many pieces of paper. So recursive is great when you're just looking for a couple terms away. Right? 1 or 2 terms away, I can add 3, 2 or 3 times. That's not a big deal. Once you get to, I want to know one that's way far out, you're going to want to use an explicit formula.
If we're doing this 20.
Okay. I'll let everybody write this down before I flip to explicit. Because explicit's not necessarily more complicated, but it can be. And for your assignments today, you have to find the recursive formula and you have to find the explicit formula.
I'm sorry, I'm really confused.
So with these, all you're doing is you're taking the term before it and you're adding your difference. Right, so I'm taking 4, I'm adding 3. Taking 7, adding 3. Take 10, add 3. So that's what this is saying. To find my new one, my next term, I take the one before it and I add 3. Okay. We're always just taking the term before and adding 3. So that's what recursive means. It means you tell me how to find the next term using the one before it. So an explicit formula expresses the nth term of a sequence in terms of n. Okay. So for an arithmetic sequence, it's A sub n equals A sub 1 plus the nth term minus 1 times d. And this is according to the book. There's another way to do it that is very similar that I will show you here in just a minute too. Okay, so A sub n equals A sub 1, or the first term of the sequence. N is the term number you're looking to find. And D is your common difference. So no matter what arithmetic sequence you're looking at, you have to find that first difference. You're going to need it to complete both formulas. And you need to know what the first term of your sequence is. And then you're going to write it in a generic form. Okay, and we have an example of this too. But this is the one you're gonna wanna write down. The other one is a recursive formula. So a recursive expresses it in terms of the previous amount. And an explicit just does it as a generic, put your number in, get something else out. Right, so if we're looking for the 100th term, instead of having to do 100 math problems, we can do one. Which I think we can all agree is better than doing 100, right?
It's either one difficult one or 100 simpler ones.
It's not terribly difficult once you have the formula. And once I show you how to find the formula, you'll find it's not so bad.
One that's more difficult than one of the 100 simpler ones. Or 100 simpler ones.
You have the formula down, Milo.
Mhm. Very small. Like, every time I notice I'm always tired, every time that's why I'm not tired, it doesn't make sense. I'm tired. I just.
Okay, so let's do an example. So this is our generic formula. Okay. So if we're gonna plug in our a sub 1 is what comes out for our first term. So we replace that with a 4. Our common difference is a 3. So I replace the D with a 3. You with me so far? As long as you have that generic one, you can just plug numbers into it. Okay. So if we want to find a sub 6, like we did last time, with the recursive, we would leave our 4, put in a 6 for our n, and then just do that math. 4 plus 5 times 3, 4 plus 15 equals 19. Is that what we got last time? We had 16 plus 3. Okay, so another way that you can do this, and sometimes it's easy, sometimes it's not. So I definitely want you to have this written down. In case it's not an easy one. But one thing you can do is you can say, okay, if this is case 1, what would it be for case 0? What would I have to do to get case 0? Minus 3. So if I did 4 minus 3, what would I get? 1. Okay, now when we're talking about linear functions, and this only works for linear functions, so keep that in mind. This common difference, what is our generic form of a line? It's the equation for a line.
Y equals MX plus B.
Or x equals mx plus b.
Yep, either one of those works. This 3, this is your slope. It's your m.
Hey, that makes sense. I actually can see this.
It does make sense. So you can plug that in.
X.
Okay. And what is our y-intercept? It's whatever comes out when we put in 0. So if you know the common difference and you can figure out what your term of your sequence would be for case 0, you can also do that. But when you write it, we can't leave it as y's and x's. Okay, that won't work. Instead, it's a sub n equals 3n plus 1. So let's try it out. Let's do a sub 7. That would mean what goes in for n?
7.
7. What do you guys think it's gonna be? If it was 16,
22.
19, we'd be looking for a 22. What is 3 times 7?
21.
51 equals to 22.
So whichever way makes more sense to your brain. Did you go get a Charlie slip? Just go get a slip for me. Okay. So it doesn't matter which way you choose to do it, you're gonna get the same results every time. This is just a little easier to graph. Right? It's a little more what we're used to seeing all the time. But either one of these would be correct. Okay, this is the same as this. This would be your equation. This would be your answer. Either that or this. Do you want me to prove that they're the same equation? Is that good?
I mean, you understood that by giving us the same answer for 6.
But let's think about it. Let's set them equal to each other and see if it works. Okay, what would I need to do first? I'm going to distribute this 3 first.
3n minus 3.
Okay, let's combine like terms. 4 minus 3 is 4.
They're the same.
So if I distributed and combined like terms, it would come out exactly the same. Okay. So if it is easier for you to plug it into here and then simplify it, cool, do that. If you see this and you go, oh, I know what K0 is, I can just plug that into mx plus b. That's cool too. Both of them would be considered correct and I would count both of them right. Ooh, that's the end. So on your assignment today, it asks you to do several things. Okay. So let's work through number 1 together. Make sure you know everything it's asking for. Everything you need to include in your answer. Seriously, guys, we need the instructions. I gave a quiz to my Tech 2 class a couple weeks ago.
And it turned out bad.
And the number of kids who didn't give me what it was asking for was mind blowing.
And
I was like, it literally laid out exactly what I wanted you to give me. And half of them ended up with 2s because they didn't answer the question that was asked.
assignment where you had to all the question things, like all the things you had to do. And
Yes.
then- And if you
You gotta
didn't
be
do
careful.
that,
We'll think
the
goes
last
around.
thing was don't do any of that, and you did it, you got the second right. This first one.
Yep. Okay, so we're gonna do number 1 together. So let's turn this off.
And go to the other example.
To which example? The recursive example, that one? Look how nicely it like matched up there. It's beautiful. Okay, so for number 1, our sequence or our list of numbers, we don't know if it's a sequence yet. So the directions say determine if it's an arithmetic sequence. If it is, so if it's not, do you have to do anything else? No, you just say it's not. Okay, if it is, find the common difference the explicit formula, and the recursive formula, and the next three terms. Okay, so for number one, we've got -5, 5, 15,
And 25.
25, and it keeps going, right? That's what the dots mean. So how can we decide if this is in fact an arithmetic sequence?
If the common difference is the same.
Right, so we're just gonna take each term and subtract the one before it. So we've got, I'm gonna go ahead and create a table, because I feel like that's just an easier way to organize my thoughts, right? So I've got my term. Got my case. I've got my first difference. Okay, so my first case is a -5. Second is 5, third is 15, and 4 is 25. Okay, so my first difference, I'm taking and subtracting the output before it. So 5 minus the -5 gives me what?
10.
Okay.
10.
-5.
15 minus 5,
10.
10.
and 25 minus 15.
10.
Okay, so is it an arithmetic sequence?
Yes.
Yes. Okay, so that's the first thing you're gonna do. Yes, it is. Okay. Then it says find the common difference. What's our common difference?
10.
The common difference is 10. Okay, so if I'm looking at my recursive formula, right, we've got a formula for that. It says that a sub n equals, what does it say?
A n minus 1
A sub n minus 1.
plus 3.
Is it plus 3 this time?
Plus 10.
Plus 10, plus our common difference. Okay. That's all you have to do, just plug the numbers into the formula. Not so bad, right? Okay, explicit formula. Is this one. So this is my recursive formula. My explicit formula says that I take a sub n equals, what is my A1? A sub 1 for this one.
-5.
-5. Okay, now I'm gonna go ahead and I'm gonna do the math, so it's as simple as it can be. Okay, now can I find my next three terms? There's an easy way to do it. You can plug it into the formulas, and one of the two formulas, it doesn't even matter which one. Or, and actually made this assignment easier because when I originally was making it, it was like, have them find the 52nd term. It's like I could, but we won't today. Okay, what's the next number that's gonna come? If it keeps following the same pattern.
35.
45, 55.
45,
That's it.
55, 75, 75, 95, 25.
That's what you need to do for each problem on your assignment. Not so bad, right? You have the formulas, just plug your stuff into the formulas. Okay, make sure you're using your N's and your A's. Okay. Any questions? We think we can do it?
Yes.
Set it up as a table. It's a little bit easier to see when you set it up as a table, because then you're just doing subtraction. Right? We all know how to do subtraction at this point in our math careers.
You should. We're in the best.
Even if it means you need a calculator, you know how to do subtraction.
In fact, looking at abstractions line breaks my brain.
If it's just a line that goes, then
Okay.
it's subtract.
The same for every song.
Yeah, the first term is always gonna be case one.
This doesn't.
I know, it looks, for me, it looks like a.
All what you just taught was my mistake. I'm not.
Put it into a table. Find the first difference. If the first difference. Literally subtraction. We're doing subtraction. 5 minus a negative 5. 15 minus 5. 25 minus 15. Okay. You're just subtracting the one before. That's it. Don't overcomplicate it.
It's like, it's not that part, it's like the explicit formula in, other than.
Okay, so for those, make sure you're just using your formula. And plugging this stuff in. Okay. I know you guys, and you're gonna overcomplicate it. It's literally just pulling the information out of what you already have. And plugging it in. Okay. Yes, Jacob.
I don't get the, I get like the first step, I just don't get. When I get this next slide.
Okay, you don't have to start solving them, right? You could leave it like this. This is correct.
We can just leave it like that.
Like just write
So
that
simple.
It's not gonna be a +10 or a -5 on every problem, right? Those numbers are gonna change depending on the problem. The 10 is our common difference. It's our first difference.
How should I make the first difference and make the?
We take the second number and subtract the first one. Then we take the third and subtract the second. Fourth, subtract the third. If they're all the same, then it's an arithmetic sequence, and that is our common difference. That is our D. Okay? Did I mention y'all were gonna overcomplicate this?
Yeah.
Oh, you're not gonna do it either.
That is your D. So if you can do subtraction, you can find your D. Then you're just plugging it in. This one is our explicit. Recursive and explicit on the board at the same time. Okay, hopefully you have these in your notes because you're gonna want them. Yeah.
Can you think this is one? Right.
Ready? This is your N. This is your A sub N. All you're doing is plugging stuff in. This one, all you're plugging in is your D. This one, you're plugging in A1 and D. Two. You know, Jeremy. Before I stop recording. Hold on just a second. I'm waiting to see if Jeremy has any questions.